Let's now take the problem 68 of your textbook. This is a problem which I have studied and found that it apparently looks like it's a very difficult problem, but at the heart of it, it's really not so. But anyway, let's try to solve this problem. Let's say a meter stick, that means a stick of 1 meter long and weighs 240 grams, is pivoted at its upper end in such a way that it can freely rotate in a vertical plane through this pivot, through this end. That means there is a meter scale. Say this is a meter scale, and here is a pivot, and it is free to rotate against this pivot in a vertical direction like this. It's free to rotate in any one of these directions. Also, it says that a particle of mass 100 gram is attached to a upper end of the stick. A particle of mass 100 gram is attached to the upper end of the stick through a light string of length 1 meter. There is a catch because the string is also of length 1 meter. So there is a string of length exactly 1 meter, and here is a ball of 100 gram. Let's call it small m, and that is 0.1 kg. And let's call this scale to be capital M, its mass, and this is given to be 0.24 kg. Now it says, initially the rod is kept vertical. We have kept it vertical, and the string is horizontal. We have kept it horizontal. When the system is released from rest, that means now you release the small mass m. The particle collides with the lower end of the stick. Of course, since both of them are 1 meter, the particle will come and collide with the lower end of the meter stick, and the point is, and it sticks there. That means this point comes and sticks there. Find the maximum angle through which the stick will rise. Now, of course, this meter stick will rise. Of course, this meter stick will rise. This meter stick will rise like this. Meter stick will rise like this. With this collision, the meter stick will rise like this. They want us to find out this angle, theta. That's all. They want us to find out this angle, theta. Now, how we solve this problem? Now, what is the linear velocity of this small particle when it hits, or just before the collision? The linear, and this velocity at the time is horizontal. There is no doubt in that. The linear horizontal velocity of the particle just before collision just before collision, if you use the formula v equal to u plus 2g, v square equal to u square plus 2gh formula, I write here the formula that you have to use equal to v square equal to u square plus 2gh formula. This is the formula you use. Then you find that v is equal to under root 2gh. V is equal to under root 2gh. This is under root 2 into g I take at 10. H is 1 meter. This is under root 20. Under root 20 meter per second. This is the velocity. Now, this velocity of under root 20, this velocity creates an angular momentum on the scale, right? This creates an angular momentum. This creates a angular momentum, and that momentum is equal to, angular momentum L is given by angular momentum L is given by mvr, mass of the body, v, and r is the mvr is the formula. So I write the formula for your understanding. So mass of the body here is 0.1. This is 100 gram mass, 0.1. Its velocity is root 20, and r, or the distance, is also 1 meter. Distance is also 1 meter. And this is 0.1 root 20. If you calculate 0.1 root 20, it is 0.447. 0.447. Now, this momentum is transferred to the joint body. This momentum is transferred the jointed body of the meter stick and the particle. Part and the particle. Here is the catch actually. Transferred to the jointed body of the meter stick and the particle. That means this angular momentum was carried in by the particle, but now it is the angular momentum of the meter stick as well as the particle. That is what we need to remember, right? So angular momentum L of the jointed body is equal to 0.447. Now we have to find out omega, the rotational speed omega that it creates. Now you have now become used to it. We have to use the formula L equal to I omega. So we have to find out I first. I, moment of inertia. What is the moment of inertia? Combined moment of inertia. What is the combined moment of inertia? The combined moment of inertia is equal to this is a rod which is, this is a rod which is rotating through axis at one end. So combined moment of inertia for the rod is 1/3 capital M, its length square, plus for the small particle, it is its mass M into L square. This is a combined moment of inertia. This is equal to capital M is given as 0.24, 0.24 by 3 L square. L is 1, length is 1, 1 square plus smaller mass is 0.1 multiplied by 1 square again. So this is equal to 0.24 by 3 is 0.08 plus 0.1 is equal to 0.18 kg metered square. So we can find out omega. Since using the formula I omega equal to L, so this I is 0.18 omega, L is 0.447, 0.447. From here, if you calculate omega, omega becomes 2.483. I have done these calculations. You can check. 2.483 radian per second. Now we go, our final goal is how much it will rise. What is the angle theta by it will kick? So if we know omega, we know the kinetic energy produced. Kinetic energy. Now we go to the next part. Kinetic energy is equal to half I omega square. I omega square is equal to half I, we have found out moment of inertia is 0.18. 0.18. Omega, we have found out 2.483. So 2.483 whole square. If you calculate, you will find the kinetic energy becomes 0.555 joule. I have done this calculation. You can use your calculator and do these calculations. So this is the first part of the question. We have found out what is the kinetic energy of this body now. Now, this scale will rise. When the scale turns by an angle theta, center of mass of the scale and the particle will rise. So we have to calculate on the center of mass. So if the center of mass is if the center of mass rises by an angle, rises by a height, say h, small h, then potential energy increased by the center of mass is mgh, and that will be equal to this kinetic energy. So, say the center of mass of the combined system rises by an height h. If we see so, then height h, then what is the total mass is capital M plus small m multiplied by g multiplied by h will be equal to this kinetic energy 0.555. Now we on the left hand side we know everything except h. So I write, so capital M is 0.24, 0.24 plus small m is 0.1 and g we take as 10. H only we do not know is equal to 0.555. From here, if you calculate, you will find, I have done this calculation already, H is equal to 0.163 meter. Now, obviously, now we have to know where is the center of mass. Where is the center of mass? Let us say its center of mass is here. Let us say its center of mass is here, center of mass. Now, center of mass rotates and comes here. And this height is actually, h, which is equal to 0.163, equal to 0.163. And say center of mass is at a distance of, x from the pivot point. So this height is also x. And we know from the geometry this height is x cos theta. That means x cos theta plus h equal to x. So we can easily find out what is the value of h. So formally we complete the job. Say the center of mass is x distance down from the top. Now we can easily find out this center of mass. Firstly, how do we find out? It's not difficult at all. I'll show you. You can easily find out the center of mass. This is a scale 1 meter long. Obviously, its center of mass is at the center. And here is a body which is at 1 meter distance. So if we take this upper end as a reference and the new center of mass is here, then and this distance we define as x. In that case, from the method of calculation of center of mass, in that case, x multiplied by total mass. Total mass is 0.24 plus 0.1 plus 0.1 is the total mass, will be equal to 0.24 0.24 multiplied by 0.5 because center of mass of the scale was 0.5 meter away from the top, plus the small particle, its mass is 0.1 and its center of mass is 1 meter from the top. Right? So from here we get 0.34x is equal to, you can calculate 0.22. And from here we get x is equal to 0.647 meter. 0.647 meter. 647 meter. Now coming to our original thought, as we thought, if this is so, then x cos theta, I'll bring in the diagram for you. X cos theta plus h, x cos theta plus h. So x cos theta plus h is equal to x. Now we know x, we know h. So x is your, or x cos theta, or from here we get x cos theta is equal to x minus h. And x cos theta is x minus h. Therefore, x is, we have calculated 0.647. Therefore, 0.647 into cos theta is equal to x is 0.647 minus h we have found earlier, 0.163, 0.163, 0.163. This is equal to 0.484. 3 and 7 makes 4, 6 and 8, 0.484. Therefore, cos theta equal to 0.484 divided by 0.647, 0.647. This is equal to 0.748. So if you now just use your calculator, you will find theta is equal to 41.57 degree. That means with this phenomenon, when a small particle falls and sticks to the lower end of the scale, 1 meter scale, both of them, it rebounds backward in a rotational motion, and it rotates by an angle of 41.57 degree. Next, we shall go to the next question.